Welcome to Educator.com. In today's lesson, we'll be discussing complex fractions, as well as the related topic of mixed expressions. Beginning with mixed expressions. A mixed expression is the sum of a polynomial and a rational expression. This is analogous to when we talk about mixed numbers, such as 3 3/4 or 4 1/8. So in the analogy, the whole number or the integer here would be analogous to the polynomial, and the rational expression in algebra, that's a fraction. So a mixed expression can be converted to a rational expression. The same way we can convert these mixed numbers into fractions, we can convert a mixed expression into a rational expression. So to give some examples of mixed expressions, algebraic mixed expressions, well, they consist of a polynomial and a rational expression. So a polynomial, such as x minus 1, x squared plus 4x plus 3, and a rational expression. A rational expression is a fraction in algebra. So it could be something such as 3x over x plus 2, or y over y squared plus 4. If I put these together, I can form a mixed expression. And an example of that would be x plus 4 plus 3x over x plus 2. Now, I can simplify these, or I can convert them into a rational expression if I could add them. And in order to add them, I need a common denominator. So in order to convert to a rational expression, I want to find a common denominator. If you think of it this way, x plus 4 plus 3x over x plus 2, you look at x plus 4, well, the denominator is actually 1. So in order to find a common denominator, we're going to use the LCM, just like we have in previous lessons. So here, the denominator is just 1. Here, it's x plus 2. So if I can use x plus 2 as the denominator in both, then I can add them together. Now, in order to do that, I need to multiply both the numerator and the denominator of this expression, of this polynomial, by x plus 2. And recall that doing that is simply like multiplying by 1, because these x plus 2's would cancel out. Okay, so if I have this and I multiply out, this would give me x squared. So x times x, x squared. The outer term is 4x. The inner term is 2x, so that's 6x. And then the last term, 2 times 4, is 8 over x plus 2. Well, at this point, I now have two rational expressions, and they have common denominators. And you recall that I can easily add these by adding the numerators. So this is going to give me x squared plus 6x plus 8 plus 3x all over a common denominator of x plus 2. This can be further simplified to give me x squared plus 6x and 3x would be 9x plus 8 all over x plus 2. And you could try factoring this out and see if you get a common factor and cancel, but it turns out that you don't. So this is as far as I can go with this. The main point is that if you start out with a mixed expression such as this, you can convert them to a rational expression by using a common denominator, converting one of these to converting really the polynomial to an equivalent expression with a common denominator, and then adding, and then simplifying. Okay, so that is mixed expressions. Complex fraction. A complex fraction is a fraction which contains fractions in its numerator or in its denominator, or in both the numerator and denominator. For example, if I have 4y over y plus 3, and then I have a main fraction bar here, and I have a y plus 2 over y. This is a complex fraction. Here, if I look at the main fraction bar, this is the numerator, and it contains a fraction. And I also have a situation here where the denominator contains a fraction as well. I could have had, perhaps y over y minus 2 over just y squared. And then I just have a fraction in the numerator, but this is still considered a complex fraction. Now, in order to simplify complex fractions, you use this formula. And thinking about this in terms of numbers or in terms of an example makes it clear. Let's look at a situation where we have a over b divided by c over d. And we could look at the situation x minus 3, that would be the a, over 4x squared, that'd be b, a main fraction bar here, so this is my numerator. This is x squared minus 9 over x cubed in the denominator. Remember that if you think back to division, if I say a over b over c over d, I could write this like this. A divided by b, so a over b, that fraction, divided by c over d. And you'll recall from earlier lessons, if you're dividing one fraction by another, you take the second fraction and multiply the first one by the reciprocal of that second fraction. And that's where this comes from. So, division of two fractions, you leave the first fraction alone, and then you take the inverse, or take the reciprocal of the second fraction to end up with this. I'm just going to do the same thing here. So I have the first fraction, x minus 3, the one in the numerator, and I'm dividing it by x squared minus 9 over x cubed. This is going to be the same thing as taking the first fraction and multiplying it by the reciprocal of the second fraction. Now that I've done this, I just proceed with multiplication of rational expressions as we did in previous lessons. And recall that what we're going to do is factor and then simplify if we have some common factors. We're going to cancel those out. Okay, so that is x minus 3 over 4x squared, that was actually 4x squared, times x cubed over x squared minus 9, and this can be factored to x minus 3x plus 3 because it's the difference of two squares. I see that I have a common factor here of x minus 3, and that cancels out, so the x minus 3's cancel out, and what I have left is, I also have a second common factor here of x cubed, so that's going to leave me with x up here, and in the denominator 4 times x plus 3. So again, just using this formula, I started out with this complex fraction. I took the fraction in the numerator, x minus 3 over 4x squared, and I said, okay, I'm dividing that by x squared minus 9 divided by x cubed. So that's the same as taking the first rational expression and multiplying by the reciprocal of the second rational expression. I went ahead and I factored out whatever I could in order to simplify, and I found that I did have some common factors. I had a common factor of x squared, and I had a common factor of x minus 3. Okay, applying this to some examples. This first example, I have a mixed expression that I'm asked to write as a rational expression. So rewriting it, 2x squared minus 3 minus x minus 2 over x plus 3. What I need is a common denominator. And really, what I have here is a denominator of 1. So I know what I really have here is a denominator of 1. So in order to get a common denominator, I need to multiply both the numerator and the denominator of this polynomial by x plus 1. And I need to do both numerator and denominator so that this would actually be 1, because it would cancel out to 1. So that makes it something I'm allowed to do. I don't need to do anything to this second expression here. So this is going to give me x plus 3 times 2x minus 3. I need to go ahead and multiply that out, which is going to give me x times 2x squared is 2x cubed. This is x times negative 3, so that's negative 3x. Here I have 3 times 2x squared, so that is plus 6x squared. And then I have 3 times negative 3, that's negative 9. All over x plus 3, which is my common denominator, minus x minus 2 over x plus 3. Now I can subtract because I have a common denominator. So subtracting, that's 2x to the third minus 3x plus 6x squared minus 9, x minus 2, but it's negative. So that's negative x, negative and a negative is plus 2, all over x plus 3. All that's left to do is simplify the numerator. So I have 2x cubed. For my x squared term, I have 6x squared. So that is 6x squared. X terms, I have negative 3x minus x, so that's negative 4x. For constants, I have minus 9 and plus 2, so that's negative 7, all over x plus 3. And at this point, we can't simplify this any farther, so we're going to leave it as it is. So starting out with a mixed expression, what we need is a common denominator, and we're going to get that by multiplying the polynomial by this denominator, x plus 3 over x plus 3. Multiply out the numerator. I have a common denominator, so now I was able to subtract. My second example, simplify, and it's a complex fraction. Recall that a over b all over c over d equals AD over BC. So using that information, I'm going to rewrite this as x squared over y squared times the reciprocal of this fraction in the denominator. So 3x minus y is going to go up into the numerator. So this is A, B, C, D. So I have A here, D is here, and I'm going to be multiplying A times D. In the denominator, I have B, which is y squared, right there, times C, which is 2x plus y. So you can always go back to the formula to clarify and make sure that you're doing this correctly. Okay, so now it just comes down to multiplying two rational expressions. So this is going to be x squared times 3x minus y over y squared times 2x plus y. Multiplying this out, x squared times 3x is 3x to the third. X squared minus y is negative x squared y over, so that's y squared times 2x, that's 2x y squared. Y squared times y is y to the third. Okay. And I'm looking, and I could pull an x out of the top, but I can't pull an x out of the bottom, so that's not a common factor. In the bottom, I can actually factor out a y squared, but there's no common y factor in the numerator. So this is actually, I can't simplify, I can't go any farther with this. So all I needed to do to simplify this was change it from a complex fraction to a rational expression by using this formula. In example 3, we have another complex fraction, but it involves more terms and trinomials. We still handle it the same way, using the formula a over b divided by c over d equals ad over bc. Okay. My numerator is x squared minus x minus 6 over x squared plus 4x minus 12. I'm going to multiply that by the reciprocal of the denominator. So this bottom expression becomes the numerator when I multiply. X squared minus 36 over x squared minus 4x minus 12. I can simplify, or I can at least try, so I'm going to do some factoring and see if I can simplify. Starting out with this numerator. Well, I have a negative here, so it's going to be x plus and then x minus another term. Factors of 6. 1 and 6. Those seem too far apart to add up to -1. So I'm going to try 2 and 3. And since this is a negative term, I'm going to make the 2 positive and the larger term 3 the negative. Let's check that. X times x is x squared. X times -3 is -3x plus 2x. That's going to give me -3x plus 2x is -x. 2 times -3 is -6. Okay, factoring the denominator. Again, I have a negative here, so I'm going to have a positive and a negative. Factors of 12. I have 1 and 12. Those won't probably add up to 4 because they're pretty far apart. Next, I could try 2 and 6. So let's try 2 and 6. And I have a positive here, so I'm going to make the 6 positive since it's larger. This gives me x squared, an outer term of -2x, inner term of 6x. -2x plus 6x is 4x. So that is correct. Last term, -12. So that's correctly factored. Times, I have the difference of 2 squares, so that's easy to factor into x minus 6, x plus 6. In this problem, the simplification is, simplifying at the end is actually more work than actually getting rid of that complex fraction. Okay, again, I have a trinomial that needs to be factored. And I have a negative here. So I'm going to have a positive and a negative. And this is going to add up to -4x. Well, before I had this situation, it added up to positive 4x, and I got plus 6 minus 2. So I'm going to try it the other way around. So this is x squared. Outer is -6x. Inner is 2x. -6x plus 2x is -4x, and that's -12. So now that I've done all this work, I'm going to see what I can cancel. I have x plus 2 up here and down here. Common factor. Okay, I have x minus 3. I do not have that in the denominator. I have an x minus 6 in the numerator and in the denominator. I have, let's see. Oh, this is an error. Let's go back just for a second. This actually should be an x plus 6. Difference of 2 squares, x squared minus 36. That's x minus 6, x plus 6. So checking again. I had an x plus 2, x plus 2. I have x minus 6, x minus 6. X plus 6, I have an x plus 6 here. Okay, that left me with x minus 3 over x minus 2. So this whole complex fraction that we had came down to first multiplying the whole rational expression in the numerator times the inverse of the denominator, then doing a lot of factoring out both numerators and denominators, and then canceling to end up with x minus 3, x minus 2. Okay, in example 4, I have mixed expressions and a complex fraction. The way to handle this is to first get rid of this mixed expression. I want to turn this into a rational expression up here and down here so that then I'm just working with the complex fraction. So let's take care of the numerator first. 2x minus 10 over x minus 3. In order to make this a rational expression instead of a mixed expression, I'm going to multiply 2x over, which is really 2x over 1, times x minus 3. I'm going to multiply both the numerator and the denominator times x minus 3. This is going to give me 2x squared minus 6x over x minus 3 minus 10 over x minus 3, which is then going to come out to 2x squared minus 6x minus 10 over common denominator of x minus 3. I'm just subtracting. So first I was dealing with the numerator. So now I'm going to write my new numerator up here, which is just a rational expression of 2x squared minus 6x minus 10 all over x minus 3. Okay, so I took care of that. Now I need to work with the denominator. The denominator I will do right here is another mixed expression, 3x plus 5 over x minus 2. Well, I need to multiply the numerator of 3x, which is really 3x over 1, times x minus 2 over x minus 2. When I do that, I'm going to end up with two rational expressions that I need to add, and they're going to have the same denominator. 3x times x is 3x squared. 3x minus times negative 2 is negative 6x over x minus 2 plus 5 over x minus 2. Okay, now that I've done that, I can add, because I have a common denominator. 3x squared minus 6x plus 5 all over x minus 2. So I simplified the mixed expression in the numerator. That's right there. Now I simplified the mixed expression in the denominator to get this rational expression, which is 3x squared minus 6x plus 5 all over x minus 2. The last thing I'm going to do is simplify this rational expression. Now, remember that this complex fraction, I'm going to simplify the complex fraction. And I'm going to do that by taking the numerator, 2x squared minus 6x minus 10 over x minus 3, and multiplying it by the reciprocal of the denominator. So that's going to give me x minus 2 over 3x squared minus 6x plus 5. Okay. Next thing is to do some factoring. See if I can simplify this, because we've got a lot of expressions here. Well, this could be, 2 could be factored out. 2x squared minus 3x minus 5 times x minus 2. Okay? Divided by x minus 3 times 3x squared minus 6x plus 5. So I was able to pull that 2 out, and you'll actually find if you try to factor these out, you should go through that whenever you have a problem to see if you can simplify. But it turns out that even though this is a pretty messy looking long expression, it actually cannot be simplified any further. So I started out with this, which had both mixed expressions and complex fractions. I first got rid of the mixed expression in the numerator and the mixed expression in the denominator. And once I did that, I rewrote it as such so that now it's just a complex fraction. And I multiplied this rational expression by the reciprocal of the other rational expression, pulled out the 2, but other than that, this really cannot be further simplified. So this is what you would end up with after simplifying. But at least you met your goal of eliminating the complex fraction and the mixed expression. That concludes this session of Educator.com. I'll see you next time.